Hello, I'm Gareth, and after the outstanding quality of the talks, many of us have understandable performance anxiety about how we could ever live up to the standards that we saw in Demuxed, next year in Demuxed if it happens, or even just in our work. So let's do a breathing exercise. We'll breathe in for 4 and breathe out for 4, and with every breath I'll give you an affirmation that we can all use to allay our anxiety. Take a seat, become aware of your surrounding, and let's begin with a breath. Your technical stack is not as good as Disney or Netflix unless you work for Disney or Netflix. Your topic may not be suitable for a demo using egg cups and water. Your assets do miss a rung or 2 or 3 on the ABR ladder because content-aware encoding is hard. You weren't to know that the electronic junk you threw out last month while decluttering was actually the key to a great talk. AV1 did go over your head, but since you've not used FFmpeg in over 18 months, does it really matter? You will never have Matt and Phil's bromance. You may not have a dog or a child lying around to increase the cuteness of your talk, but you know what? You're above that as a presenter. Phrasing questions to ask can be hard, and sometimes you'll stumble, but don't worry, you don't need to, because Nick has already done it. You're not using Quick. Yes, it's new and exciting, and yes, you do want to avoid head-of-line blocking and all the other cool stuff it does, and yes, it has been on your roadmap for months, but until your product manager really understands how stressed the team are operating in a global pandemic, nothing is going to get done. And coming back to the breath, I hope that really leaves everyone feeling calmer, ready to face 2021 if we escape the hellscape that is 2020.
2, 1, go. You're live, Hampton.
How's it going, everybody? My name is Hampton, and I'm CEO of a company called Vue, and I am new to the community. And so what better way to start than make bold statements about how everybody's doing stuff wrong? It's just a good way to build relationships and have people like you. All right, look, I think some therapy needs to happen here because I know what the past, all that you all have been doing to make video work on the internet has been. The connections are so slow, they're spotty, it's like 3G and then dial up and like the real player with like the little blurry images, and like that's been the reality of what it takes to do video on the internet. And like, you know, this is basically like, how do we not have this happen? Well, the future is now. Stuff is happening, 2020, it's going on. Starlink, if you haven't heard of this, I believe this is going to change this industry entirely, and many of them. Starlink is Elon Musk's idea to launch a bunch of mini satellites all around the planet that talk to each other with frickin' laser beams, and they talk to each other and they make the internet go to the entire world. High speed, nearly fiber internet to the whole world, the center of South America, Africa, the whole, every part of the world, high speed, reliable internet. And also 5G, that's going on, which I might even lose to, we don't even need it anymore. We just got the internet everywhere. This is huge, like fast internet all over the world for less. Bandwidth is here. We have the bandwidth for video. I know it's not here today, but it's going to be there soon. So we need to be ready for this as an industry. There's a lot of the technology has been going on to how do you deal with low connection speeds and variable bit rates and all sorts of things. But I think the big challenge is going to be who can handle millions of 8K streams from people who've never had internet before, but now all of a sudden are hitting us. Like, I think that is actually going to be the biggest challenge coming up in the future. I'm Hampton. Nice to meet you. Bye.
Amazing. Thank you, Hampton. All right, we're going to cut over to Steve Robertson's talk.
If you're producing SDR video, you should use BT709. If you're a video service, you should be delivering your SDR using BT709 when possible, and maybe even convert niche formats to BT709 so they'll be more consistent across devices. Screen capture, like live streaming a game, is a special case. Screens use sRGB, not BT709. sRGB uses the same color primaries but has different transfer characteristics, or what we might say casually, has a different gamma. If you send a dark gray signal to an sRGB display, like a computer monitor, it would show up a little bit brighter than if you sent it to a BT709 display. Although interestingly, the BT709 standard doesn't tell you how to display a BT709 signal. Instead, we care about reproducing what the colorist or production team saw on their displays, and for that we use BT1886, which basically says that to show BT709 content, you should use a gamma of 2.4 and an ambient illumination of 8 lux, like a dark home theater. sRGB uses a gamma of about 2.2 and an ambient illumination of about 64 lux, like a home office. The difference between a gamma of 2.2 and 2.4 is noticeable. Does that mean that if a video platform gets sRGB content, it should convert it to BT709? No, and here's why. The sRGB gamma curve is specified for use in a much brighter environment than BT1886, 8 times brighter according to the spec. That reduces our ability to see detail in the shadows. An image that looks good in a dark room looks too dark and contrasty in a bright room. One way to fix that is to turn down the gamma, making dark grays appear brighter. And remember, that's exactly what happens when you display BT709 content on an sRGB display. The process works in reverse too. sRGB happens to look good without conversion if it's played on a BT1886 display, when that display is in a dark room. Now, the two compensated functions are still not exactly the same, but there are other costs to converting too. For instance, converting will amplify banding, especially if you're a streaming service and all you have is an 8-bit YUV deliverable. So it's complexity that doesn't really help and could make things worse, which means it's safer for video services to not apply any sort of conversion here. If you're writing video capture software that's doing screen capture on the client, you probably convert RGB 444 full range to YUV 420 studio range before compressing. My current thinking is that you should probably just do this carefully and tag the result as 709, but we're still having a big discussion about this and need to do more testing. Give me a shout if you want to learn more or think I'm wrong or whatever. Thanks.
Hi, Keyframe is a project to implement a self-hosted streaming service akin to Twitch. I'm new to most of this. I've been doing this for about a year. If I can do it, you probably can too. I started working on ingest, part of Keyframe, to get from 6 to 18 seconds of latency that I had with Nginx RTMP module down to 2 to 4 seconds, because I wanted to chat with my audience while playing video games. I used Rust. I wanted to be able to drop down the abstraction layers as necessary. I implemented a custom ring buffer, for example. I use SRT as my ingest, as RTMP is underdocumented. I talked to a production services engineer friend about this, and it's supposedly great for future-proofing, as I'll be able to do high bitrate, 8K, etc. I use GPAC as the packager, which is great software. It's absolutely amazing. It stretches out video to a variable frame rate stream properly if we drop video packets during SRT, but it doesn't insert silence if there's lost audio packets, so I had to build that myself as a GPAC plugin. ingest also contains a custom HTTP server for low latency CMAP streaming. I used GPAC and mp4box.js to inspect package output for debugging, along with a lot of GDB work on GPAC, which resulted in issues being filed with GPAC. It's great software. It's been used to simulcast production streams and hasn't fallen over, which I'm very impressed with. And I also use it a couple of times a week to stream video games, and it seems to be working. I'm very happy with it. So yeah, if you are interested in using Keyframe or AngelSD, the URL is
30 seconds.
keyframe.live. Thank you.
Hello, my name is Amita Pulijala, and I work for Vonage. Today I'm going to talk about live interactive broadcast with WebRTC. The world has turned around where most events, concerts, which were held at physical locations are now happening virtually. In this virtual scenario, providing an immersive experience is very critical for audience engagement. There are many use cases where audience interactivity is super important, but so is sharing the content with large group of audience. A quick example for this is an event where you would invite 2 or more speakers on the stage for the presentation, or where a keynote is being broadcasted and at the same time you would like to have breakout sessions to discuss various topics. Such are the use cases where WebRTC technology becomes key. If your use case requires interactivity, you should use the large interactive video broadcast feature to serve your real-time audience. Each audience member could potentially publish a stream to the session to interact with other publishers of live streams, such as host or presenter. HLS should be used to serve larger capacities, like burst capacities, where the audience size exceeds what can be supported in real time in an interactive broadcast. An HLS viewer will receive the content at a latency. So it is not very useful for interactive use cases. Customers could build additional logic in their application to move a viewer from HLS to real-time and vice versa. In this case, the application may include capabilities to manage the latency difference between HLS and the real-time viewer. You can serve HLS content to viewers on clients that do not support WebRTC. You can also use RTMP to push content created on the WebRTC session to social media video platforms such as Facebook or YouTube Live. For example, you may provide an HLS stream to a client if the WebRTC session has reached the connection limit for interactive broadcasts. The HLS or RTMP stream can be a single video composed of individual streams published to the WebRTC session. With Vonage APIs, we provide the option to prioritize the streams for HLS content. HLS streams support an unlimited number of viewers. RTMP streams are limited by number of viewers supported by the RTMP provider. If you would like to know more about how this is done, please check out our code on GitHub. Here's the code on the GitHub. Take a look at it, download, use it, and let us know. Thank you.
Hey, I'm Hef. I talked about web components yesterday. I mentioned that I have 2 babies born 3 months apart. Not above that as a speaker. You all asked for a lightning talk on the story. So here we go. You've basically given me every parent's dream an excuse to show hundreds of people pictures of my kids. So yeah, let's do this. Hopefully you can see that. This is Sparrow on the left. She is 6 months old. That's Reed on the right. He is 3 months old. That's Ruby in the middle. She's 8 years old. See, that's Reed playing his first video game. He's obviously gonna be a Twitch streamer. Them at the dinner table. This is my submission for Mux's pumpkin carving contest. And this is my submission for Mux's costume contest. Definitely an unfair advantage with the babies. This is my wife on the left, Jenny, and this is our surrogate on the right, Justina. So a little bit of a spoiler there. The story goes, a little bit of sad stuff first. My wife and I had a lot of miscarriages while trying to get pregnant. Miscarriages happen a lot. They happen a lot more frequently than you might think, and people don't talk about them a lot. I think it'd be healthier if we did, but that's the case. And we had enough where our doctors were like, okay, something's wrong here. So then we turned to IVF, in vitro fertilization, where you combine your stuff together, make an embryo, test those embryos, genetic testing to make sure there's no chromosomal issues, which were the reasons for a lot of our miscarriages. Take one of those embryos, transfer it to my wife, hopefully she gets pregnant. And we did that 3 times, all 3 times failed, super sad. Yeah, very emotional couple of years. pretty painful. So we decided to turn to a pro, a surrogate. Surrogate is a woman who's had a bunch of children, is done having children, and willing to carry a baby for you. Any woman who's
30 seconds, sorry.
a baby for you is amazing. And so this Justina, our surrogate, we got 90% of the way through the process of doing surrogacy when my wife got pregnant. And we thought it would be a miscarriage also, so we went forward with the surrogate, but surprise, both pregnancies were successful. So been a ton of work, but it's the happiest ending we could think about for our story. We call them our science twins. Still trying to find a shorter way to tell this story. I'm happy to talk about this with anybody who wants to talk about any of those details in our experience. But there you go, Tiger King teaching you about infertility.
All right, thanks, Hef.
Hi, I'm Ryan Harvey, and I work on video encoding at TED. Last year at Demuxed, I introduced a new Node.js library, Fasonia, that we built for interfacing with FFmpeg. Today, I wanted to give you an update on the current state of that library. In last year's talk, I started with a conceptual model of an FFmpeg command that guided our library API development. Then we dove through a detailed example of an actual FFmpeg command, breaking it down into components and translating that into JavaScript using Fasonia. If you missed that talk last year, you can find it on YouTube, and it's linked from the library homepage. So where are we now? Well, for the last 2 years, we've been working on a major project to rebuild our encoding pipelines at TED. That project is now in production and battle tested, and we've started moving some of our major encoding workflows to the platform. The encodes we do in those workflows are complex, producing both streaming products and downloadable video, and involving multiple FFmpeg runs for the same media product. We've also used Fasonia for ad hoc work and experimentation, day to day. On the open source public side, we've also seen some growth. Downloads spiked to over 500 per week back in April, and have hovered above that number since, peaking at almost 1,000 weekly downloads a few weeks ago. The library is now at version 2.1.2, and I'd like to give you a rundown of what's changed since version 1. We've made some changes to the handling of filter chain and filter graph objects, including support for adding nodes to a filter chain after creation, and simplified filter chain input and output handling. We've also changed our output map handling to better match that of FFmpeg, only adding explicit map options when specified by the user. We've altered process handling too, removing the failure event type because it wasn't well distinguished from the error event type, and modifying the way progress reporting is done for better reliability. So where are we going next? Well, here are some ideas we've thought about, and we'd love your help with them. One of the things we're really interested in is an idea of an introspection API for library objects like filter chain and filter node. This would help both with simplifying some of our automated testing, as well as provide an easier mechanism for human verification and exploration of Fasonia-based code. We've also heard from you that you want TypeScript support, and we'd like to support that, although we don't use TypeScript internally, so we'd love your help with it. Finally, better support for FFmpeg outputs and errors, and some support for FFprobe are things we're considering, but we'd like to hear from you what would be useful there. If you haven't already, please do try Fasonia and give us some feedback. And if you're so inclined, we'd love to have your help making it even better. You can always submit a pull request or create an issue, or if you're not sure what to do, reach out with questions. Thank you very much, and we hope to hear from you soon.
Hello, I'm Bobby Peck, engineer at Brightcove, and a couple months ago had a frustration, so I built a thing to answer that and sharing it here in case it helps anyone else with that same frustration. So oftentimes would curl an HTLS manifest and get back a wall of white text. Not very useful, fairly hard to grok, especially frustrated when dealing with a JSON REST API, going back and forth when I have the tool JQ to be able to work with JSON in a useful manner. So enter what I built called HLSQ. This one let me add some color to these manifests. Makes it a lot easier to grok and deal with. With that, don't want to stop just there. So added some basic filtering to this. So on any HLS attribute, can search for, let's search for codecs for HDBC, and there they are. And so it's fairly straightforward, just written in Go. Install is a Go install. And in honor of Demuxed, and to match the t-shirts, added a special color palette for that. And there we go. So let me know what you think. Hope it, if you have the same frustration, hope it helps you as well.
Hi, James from Mux here, and today I wanted to talk a little bit about measuring time to first frame. So first off, let's define time to first frame. That for me is going to be the time from when the viewer intends to start watching video to when the first frame of video actually starts beginning to play back. So that should be fairly straightforward. We have in a web world the play and playing events from the HTML5 video elements. So we've got the timestamp from when they click play. We wait for the video to load, and then we can get another timestamp from when the video actually starts playing back. So that means time to first frame is essentially the difference between the play and playing events. And we can see this happening in real life here. This video I've throttled just to kind of elongate the startup time, but essentially we're taking a timestamp from the play event, waiting for the playing event, which we've just got, taking another timestamp, diffing the two, and you can see in this example it took just over 7 seconds to get the video to start playing back. And that works most of the time pretty well, except for when it doesn't. So if, like me, you're a bit of a skeptic, how reliable are those play and playing events from the device or the browser that you're using to play back video? So autoplay is a good example of this. Adding that autoplay attribute seems fairly harmless, but actually it throws in a whole load of questions for, did the video actually play or not? Did the video try to play and then did it fail? And actually when it failed, did it then pause again? Or did it send some event to basically say, I'm not trying to play anymore, so that we can stop trying to measure time to first frame? And actually, does it send play at the right time altogether? Does it wait too late before it actually sends the play event? So, you can work around this with a bit of JavaScript, fairly straightforward down there in the bottom corner, but just a bit of a shame because obviously you would prefer not to have to do that when you're using the autoplay attribute. And what about other devices? I've done talks in the past about set-top boxes in particular and smart TVs. Their events can come from all over the place. And actually there's cases on just regular web players in certain browsers where the events aren't necessarily as reliable as they could be for measuring this stuff. I'm not going to name and shame anybody, which is why we've got the happy world on the screen. But it's definitely something that's worth checking. So how can we work around it? We could use a different approach. Instead of relying on the playing event, we could look for the first time update event and then do some maths to basically retrofit the time for first frame this way. The only problem with that is actually when it comes to live streams or any streams that have got programmed date times in it, you could find that actually once the playing event starts, the elapsed time of the duration of video that's played by that first time update event may no longer be what you'd expect, so it can completely throw things off. So how about testing it? How can you test your player to know if your playing event's coming at the right time? Well, actually, we can use the canvas element in HTML and basically extract the first frame and check that it really was the first frame on playing event, as you can see just here. That's all I've got time for. Thanks very much for listening. Cheers.
Hey everybody, my name is Nick. You probably know me from @Nick in the video devs world. And so today I'm here to do a plug for Awesome Video. And so here we go. If you're not familiar with Awesome Video, pretty much it's awesome lists just like that and put together all around the world of streaming. And so mainly it came from my need to, over the last 4 years at Fubo TV, to basically learn everything relative to the world of video and what HLS was and going through those things. And basically I kept a list of bookmarks, and then eventually last December, I put together those bookmarks into a nice little website and a repo. So here is Awesome Video. I basically today, if you guys saw on the Demuxed channel, I finally updated another 300 links here. And so we're just about 700, almost 800 links in total now. And so you can go through all the different stuff, right? Etc. There are a couple of duplicates and whatnot in here, but the reality is it's supposed to be for everybody from if you know nothing about video to also if you actually work in video on a daily basis, right? And so I went ahead and opened up some issues on the repository of things that I need some help with. And basically I would love for the community here to be able to actually contribute some things or just genuinely tell me what you guys think. And so big thing right now with over 800 links is really the recategorization of stuff. I'm not 100% sure the current set is actually doing things, doing the world justice there. Also, I found awesome broadcasting. There seems to be some interesting links there. I do not come from the broadcast world, and so I'd love somebody to go through and figure out what things would work well in awesome video. And then some video production links, because I know that the world of video production right now is huge, especially from the work from home world, right? So I will quickly show anybody who wants to contribute how to contribute, right? All you would do is obviously fork the repository, and then eventually you just go to the contents.json in your repository, and everything is laid out in a nice little schema, right? For the sake of this call, I'm going to commit to master. Don't tell anybody. And I have
30 seconds.
And I have two things I want to update, right? We have a new HLS spec. And that's where we're going to be able to fit in here, I think. And so now I've updated the latest HLS spec.
And we're out of time. Over to you, Ed. Go ahead.
Thanks, guys, and hi, everyone. I'm Steve Thorpe from Fox, and today I'd like to share a look behind the stream of Super Bowl 54 and our war room operations that enabled us to pull off the big game. Now, February 2nd seems like an absolute eternity ago at this point, but this event was memorable for a number of reasons. First off, it was the biggest Super Bowl stream ever, supporting over 3 million concurrent viewers. This was also the first Super Bowl to ever be produced and streamed in ultra-high definition with high dynamic range. And it was built on a super resilient tech stack that our team spent well over a year building. Now, for an event this big, we only had one chance to get it right, and said simply, we couldn't fail. So that meant getting ready for the oh shit moment and being prepared for anything. To get ready for this, we focused on end-to-end observability, completed numerous rehearsals and full production tests, and made sure the team had low-level visibility into all parts of the ecosystem. We built and tested extreme levels of resiliency, and overall, we operated with a one-team mentality that really paid off on the day. Now, for an event like this, preparation is key, but so is that supporting infrastructure, and we built an awesome war room to support the day. Our war room needed to support over 200 team members, partners, and support staff, have representation from all key vendor partners, and provide end-to-end visibility into our video quality, API health, CDN delivery status, and monitoring of absolutely every component in the stack. This facility also had to be highly redundant, take into consideration the power, network, and communication needs of this large team. So let's take a peek into what it was like building and running this awesome war room. For an event this big, we had to find a space to match. Thankfully, the historic Newman scoring stage on the Fox Studios lot in Los Angeles provided the 7,500 square foot blank canvas we needed to converge under one roof. Working around the clock for 48 hours straight, we installed more than 40 gigs of temporary internet connectivity, 200 Ethernet drops, 60 landlines, 20 Wi-Fi access points, and just in case, 2 satellite phones. Additionally, over 150 monitors, 2 theatrical-grade projectors, and 400 amps of on-site power were deployed. We built out a dedicated quality control room where the UHD and 720p video, audio, and caption services could be monitored, and we organized robust procedures to identify, track, and close any minor incident, wobble, or customer feedback in real time. In the end, the day was a huge success, and within just a few hours, everything was returned back to zero, ready for the next orchestra to move in. Wow, what a fun event. It really did take a village, and I just want to say a huge thank you to everyone involved. Well, with that, I'm at my time. Thank you very much.
And we're live with something a little bit more amateur than what you just saw. Take it away, Phil.
This is Phil from the other angle of his room. I promise there's nice shiny stuff over here. Anyway, as is tradition, I'm going to talk really quickly about how Demuxed works. It's a little bit different. So this is a behind the scenes of Demuxed 2020 Discontinuity Edition. So this is two fantastic engineers and Phil really behind most of this. me, who did the pre-production, kind of running pre-production flow and the signal flow. Dylan, who built a lot of services and all of the front end to all this, and obviously Ed, who did all of the kind of the production, live production. So going in order, people asked how the talks were produced. So it's something like this. We ask people to record either 2 video files or 1 video file, where one is their face and one is their slides, or put them together, usually using OBS. Then we send them to this amazing guy in the middle, Tim. He's in Video Dev Slack right now. So go and at Tim and be like, hey, Tim, well done. Thank you for editing all these talks together. And then Tim produces this nice shiny thing on the right-hand side. It's kind of a bit of a lie. The text overlays are all applied live. So really all you've got is the background, the Demuxed logo, the slides and the head. So you'll see some nice fancy face tracking and stuff in there, but works really well. So that's great. The signal flow is a little more complex than it would usually be. So everything originates in Ed Studio from vMix instance. Then we go into 2 paths with that. The first path goes into EEG Falcon, which is a cloud-based captions injector. What that does is it takes something that doesn't have 608, 708 captions in it and puts 608, 708 captions into it. We do that by talking via a product called iCap to Redbeat in London, who are doing a great job of live captioning all these lightning talks right now. But Ed's vMix also pushes a backup into Mux US East 1 as just a backup stream. Then we have 2 streams coming out of EG Falcon that goes into Mux in primary and secondary region. And then we also have a disaster recovery, RTMP, and another destination if we need it. That's my bit, and I'm going to hand over to Dylan.
Hey y'all, so I'm gonna talk about the front end. Is Phil sharing the slides? Okay, the front end.
Man, I failed you. You can have an additional 10 seconds. I'm so sorry.
The front end is our static middleman Ruby Demuxed 2020.demuxed.com site, and the new thing this year was a live page. The live page is actually an embedded iframe that we built with that embeds a Next.js React app deployed to Versal. That all worked really quite well. So that's the UI that you see on the website. We can jump to the next slide. And you may have noticed that we used 3 different layers. Day 1, we had Video.js plus HLS.js. Day 2 was pure Video.js. Day 3 was player plus HLS.js. Next slide. Let's look at some metrics from these 3 players. This playback failure rate for day 2. Next one. Player plus HLS.js, the lowest playback failure rate. Next slide. And day 1 was in between those 2. Next slide.
3, 2,
skip to the next one. These are rebuffering.
Hi, I'm Ed. I'm Fantastic Engineer number 2. Take a look at this. This is the desktop capture for the vMix setup. It is an ongoing absolute disaster. Please ignore the gentleman down there. They're very, very noisy. Yeah, so vMix is a video mixer. You've probably seen similar stuff with OBS, stuff like that. However, vMix lets us do all sorts of this nonsense. For example, when folks come in through the video calls, we can just do this, and I can capture their attention real quick. We are pulling everything in through this Google Sheets. It's extremely, extremely helpful to not have to randomly type things. I keep moving it so I can see my own face. We also are using vMix Social for all of your Twitter purposes. I just sent something to the break screen, I think. I don't know. But yeah, so thanks to everybody for helping us out with this. Thanks to all of our guests for being super on the ball. We have been doing a lot of audio leveling, a lot of other stuff. So
thanks for everybody for jumping in. Those are always a ton of fun.